to the next point. We should ensure that whatever we see is clear.
That means work is being done. If we can see that it is in opposite direction. It is clear. Good day, learners at home. Once again, you are welcome to today's physics lesson on radio and television e-learning program of Ministry of Education, Kaduna State. Today, we are going to continue on our topic, conduction of electricity through liquids, part 2. We've already taken part 1. The outline is as follows. We have Faraday's laws of electrolysis, applications of electrolysis, then at the end, an assignment for you to do at home. Now, Faraday's first law of electrolysis. The law states that the mass of any element deposited during electrolysis is proportional to the quantity of electric charge passing through an electrolyte. So mathematically, we have small letter m directly proportional to capital letter Q. Now, if we remove the sign of proportionality, we will now introduce a constant. And therefore, we have small m to be equals to small z times capital Q. And we call it equation 1, where our small m is the mass of element in kilograms, while capital Q is the quantity of charge in coulomb. Then our Z is a constant called electrochemical equivalent, and we use small letter e, small letter c, and small letter e to denote electrochemical equivalent, ECE. But we know that quantity of charge is equals to current times time. So we have capital Q to be equals to capital I times small letter t, and we call this equation 2, where our I is current in ampere, small t is time in seconds. Now, if we substitute equation 2 into equation 1, that means we are going to replace Q with IT in equation 1. We will therefore have M to be equals to ZIT, and we call this equation 3. Now, this equation 3 can be used to calculate any of these quantities, either mass or electrochemical equivalent, or the current passing through the electrolysis, or the time during which the process takes place. Electrochemical equivalent. Electrochemical equivalent, ECE, of a substance is defined as the mass of the substance deposited during electrolysis when 1 ampere of current flows for 1 second. Now let's take examples. Question 1, 1a. What is meant by the statement that the electrochemical equivalent of copper is 0.00033 grams per coulomb? B. A thin metal plate, 8 centimeter by 5 centimeter, is to have a layer of copper 0.15 centimeter thick deposited on both sides. If a current of 0.8 ampere is to be used, how long will it take? Electrochemical equivalent of copper is given as 0.00033 grams per coulomb. Density of copper is equals to 9 grams per centimeters cube. Now, if we look at the question, it is asking us how long. That means the time it will take. So what we are asked to find is time. Solution. We take The first one, A. The statement that the electrochemical equivalent of copper is 0.00033 grams per coulomb means that when a current of 1 ampere flows through a copper solution for 1 second, it deposits 0.00033 grams of copper. Now, the B part, collecting our data, we have length of the metal, capital L, as 8 centimeter. Breadth of the metal, B, is 5 centimeter. Then thickness of copper deposited on each side of metal, small d, is equals to 0.15 centimeter. And the current given, capital I, is equals to 0.8 ampere. And the time taken, small t, is unknown. That is what we are asked to find. Now, if you look at from our equation, M is equals to ZIT, you will see that T is what we are looking for. But we have I, current is given, okay? We have Z, electrochemical equivalent given, but we don't have mass. M is not given. So therefore, there's no how we can calculate T without M. So therefore, first and foremost, we have to go and calculate mass, M, before we can now substitute in our equation to get our time. So we have area of one side of metal, A, is equals to length times breadth, which is 8 times 5, and that gives us 40 centimeters squared. Then volume of copper deposited. Volume is equals to area times thickness, which is equals to V is equals to capital A times small d. Substituting our values, we have V to be equals to 40 times 0.15, and that gives us V to be equals to 0.6 centimeters cube. So now we have volume. And in the question, density was given. So we know the relationship between mass, density and volume, as density is equals to mass over volume. So we have density, we have volume. Now we can get our mass before we go back to substitute in our equation to get our time. Mass of copper deposited. So mass is equals to density of copper times volume of copper deposited. So small m will be equals to 9 times 0.6. Therefore, m will be equals to 5.4 grams. Now our formula, mass m to be equals to ZIT. If we make T the subject of the formula, because that's what we are looking for, we have small t to be equals to m over Zi. That means our mass divided by the product of electrochemical equivalent and current. So we have small t to be equals to 5.4 all over 0.00033 times 0.8. And that gives us small t time to be equals to 20454.5 seconds. Now, this is the time it will take to deposit copper on one side of the plate. And the question asks us to calculate for both sides. So, to deposit copper on both sides of the plate, the time will be 2 times 20454.5. And that gives us 40909 seconds. And that is our answer. Now we take Faraday's second law of electrolysis. The law states that when the same current passes through different electrolytes for the same time, masses of the elements deposited are proportional to their chemical equivalents. Therefore, we have mass of elements A. Let's say we have elements A and B. So we now have mass of element A over mass of element B to be equals to chemical equivalent of element A over chemical equivalent of element B. Faraday constant, the quantity of electricity which liberates the grams equivalent, which is the same as the equivalent mass in grams of any element in electrolysis, is called Faraday constant. It is represented by the symbol capital F and has the value of 96500 coulombs approximately. Examples: 1. In a copper voltmeter, a current of 2.0 ampere flows in the circuit for 8 hours. Determine the change in the masses of the electrodes, given that grams equivalent of copper is equals to 3.15 grams and Faraday constant is equals to 96500 coulomb. Solution. Our current I is given as 2.0 ampere and the time small t is equals to 8 hours. So we have to convert the 8 hours to seconds, and that will be 8 times 60 times 60. We convert from hour to minute, then from minute to seconds. So 8 times 60 gives us 28,800 seconds. Quantity of electricity passed, Q, is equals to IT. That's current times time. So Q is equals to 2 times 28,800. And that gives us Q to be equals to 57600 coulombs. Now, 1 Faraday liberates 31.5 grams of copper. But 1 Faraday, we said, is what? 96500 coulombs. Therefore, 96500 coulombs liberates 31.5 grams of copper. Then 57600 coulombs liberates X grams of copper. Therefore, X grams of copper will be equals to 57600 times 31.5, all divided by 96500. Therefore, X grams will be equals to 18.8 grams. Therefore, the masses of the electrodes changed by 18.8 grams. Question number 2. A current of 3 ampere passed through a solution of mercury salt for 30 minutes. Determine the volume of mercury liberated. Electrochemical equivalent of hydrogen is given as 0.00001044 grams per coulomb. Chemical equivalent of mercury is equals to 200.6. Density of mercury is equals to 13.6 grams per centimeters cube. Solution. Current I is equals to 3 amperes. The time taken, small t, is equals to 30 minutes. Now we have to convert from minutes to seconds, and that will give us 30 times 60, and that gives us 1800 seconds. Mass of hydrogen liberated, M, our formula, is equals to ZIT. That is, mass is equals to electrochemical equivalent times current times time. So M is equals to 0.00001044 times 3 times 1800. And therefore, we have M, our mass, to be equals to 0.056376 grams. So we have mass of mercury over mass of hydrogen. Mass of mercury, mercury has the symbol of capital H and small g. Then our hydrogen molecule, H2. So we have mass of mercury, Hg, over mass of hydrogen, H2, to be equals to the chemical equivalent of mercury, Hg, over chemical equivalent of hydrogen, H2. Okay, so now we are going to substitute in our value. So we have mass of mercury, Hg, over 0.056376 to be equals to 200.6 over 1. And if we do our cross multiplication, we will now have mass of mercury times 1, which will give us mass of mercury, to be equals to 0.056376 times 200.6. And our mass of mercury will be equals to 11.31 grams. Volume of mercury is equals to mass of mercury over density of mercury. So volume of mercury will be equals to 11.31 divided by 13.6. So volume of mercury, Hg, will be equals to 0.832 centimeters cube. Now, students, I believe you were able to follow the calculations. I believe when you are given a question, you can be able to make an attempt. So the next we will look at is applications of electrolysis. One is electroplating. This is the process whereby an inferior metal is coated with a superior or costly metal, such as silver or gold, in order to prevent the inferior metal from corrosion and also to give it an attractive appearance. Application number 2, extraction of metals. The metal ore is treated with strong acid to obtain a salt. The solution of such salt is electrolyzed to liberate the metal. Number 3, electrolysis is used in purification of metals. The anode is made of an extracted metal. If you remember, in our part 1, we said electrodes, they are the solid conductors used in an electrolysis. And the anode is the positive electrode. So the anode is made of an extracted metal. The electrolyte is made of the metal solution. The pure metal is then deposited at the cathode during electrolysis. And finally, number 4, it is used for the production of chemicals. Many chemicals, such as caustic soda, which is sodium hydroxide, chlorine gas, potassium permanganate, KMNO4, etc. are manufactured on a large scale by the process of electrolysis. With this, we have come to the end of our lesson for today. But before I go, I will call on my colleague, Mr. Napoleon Kure, who will come and summarize what we have discussed so far and then give you an assignment to do at home. I remain Hassan Buki. Thank you and see you in our next lesson.
Hello, learners. You are welcome to another session of our e-learning program. The subject physics. I'm Napoleon Kure. We are looking at the second part of conduction of electricity through liquids. And on that, we look at two major laws given by Faraday. And the first one talks about the relationship between mass and quantity of charge, M and Q, and which is given as M equals to eventually ZIT. That is very important, a formula. If you can remember that, it will ease the work or the statement. You can use the mathematical statement to interpret the normal statement. Then the second law talking about relationship between masses and chemical equivalents. And also that can be used as a mathematical tool to help you know what the statement is giving. And examples have been given by my colleague Buki Hassan, which I expect you to go over them. And we have an assignment which we want to also give you so that I can keep you busy at home. On the assignment, number 1, when a current of 3 ampere was passed through an electrolyte for 7 minutes, 39 grams of copper was deposited. Find the mass of the copper deposited when a current of 5 ampere flows for 5 minutes. Question 2. Determine the mass of hydrogen liberated in acidulated water voltameter when a current of 8 ampere passes through it in 39 minutes. Electrochemical equivalent of silver, that's ECE of silver, is equal to 0.00118 gram per coulomb. And the equivalent weight of silver is equal to 108. I take over the assignment again. Number 1, when a current of 3 ampere was passed through an electrolyte for 7 minutes, 39 grams of copper was deposited. Find the mass of the copper deposited when a current of 5 ampere flows for 5 minutes. Question 2. Determine the mass of hydrogen liberated in acidulated water voltameter when a current of 8 ampere passed through it in 39 minutes. Electrochemical equivalent of silver is equal to 0.00118 gram per coulomb. Equivalent weight of silver is equal to 108. References: 1. New School Physics by M.W. Anyakoha. 2. All-Inclusive Calculations in Physics by Solomon Dauda Yako. 3. Senior Secondary School Physics by P.N. Okeke and F.W. Anyakoha. With this, I want to give you our contacts through which you have any question, you have anything bothering you on what you have presented, you contact us with it, either through text or through WhatsApp. Hassan Buki, 080 65 50 43 46. Hassan Buki, 080 65 50 43 46. Napoleon Kure, 080 36 36 2105. Napoleon Kure, 080 36 36 2105. You are advised to stay at home as you remain safe and keep on learning. Till we meet in our next lesson. Thank you. Good day.